Start?
Yes.
Okay. Welcome from Madrid, Spain. This is EDIBON International, and I will be explaining the free and forced vibration unit. So this is the more advanced unit of 2 units. There's also a free vibration unit. First I will explain the free vibration parts that are involved. The system comes with 3 springs of 3 different stiffnesses. One is installed here, 2 more are off to the side. It has a mass carriage that rides along 2 vertical rails, and there's also a Dashpot, which is a adjustable damper, and there's a drum recorder which allows you to take recordings of the vibrations as they occur. And the Dashpot is adjustable. You may add weights to the mass carriage, and you can interchange the springs that are involved. From there, there's the force vibration part of it, which involves a variable motor located behind the machine, which powers this drum recorder here, as well as a actuator or a crank that actuates this position up and down, causing a position change in the support of the spring, as well as here you are able to connect this device and put it on here, and this uses a off-balance weight that rotates and causes a vibration, or a force that causes a vibration. I guess.
Okay, Michael, can you show us the box?
You want me to bring it, or?
Yes. Okay, better.
Like that? Alright. Okay. This is the electrical control box. You're able to power on the system using this button. There is a vibration display, which is taken from a sensor here on the machine, and you are able to turn on the recorder drum over there, as well as turn on the motor, which powers the system, and there's a variable dial to change the speed of the motor.
Okay, thank you. Okay, there's another unit, the free vibration unit.
You want me to?
Okay. What can you tell us about the unit?
Okay. The free vibration unit essentially removes the forced vibration part of this unit, which still has the spring, the drum recorder, the synchronized motor, the Dashpot, as well as the mass carriage, and you were able to do any vibrations with a spring mass damper system, which allows you to adjust the damping constant of the Dashpot down here, as well as change the weights and change the springs. And with those different combinations, you can learn about how different spring constants affect the vibrations, as well as the weight and the damping.
Okay, perfect. And now, can you show us how is working the unit? A briefly demonstration about it, about the free and forced vibration unit.
Okay. Yes. So I'm going to adjust the damper so that it is slightly open, I believe.
Okay.
And
Michael.
I don't know what I'm doing.
At the back. Yes. Okay.
What should I don't know what to show.
Okay. Eva, who is the person in charge of designed and design the unit and help to their engineers to manufacture the unit. She will help Michael to make your demonstration. Okay. What are you setting, guys?
We are adjusting the weight that is on the mass carriage, and we're adding 2 kilograms to the 1.7 kilograms that already exists on the mass carriage itself. So it's
okay. Okay, and then you are connecting. Oh, okay. So you can explain more or less what it happens?
Yeah, the variable motor is powering the crank here, and it's causing the top position to change, which is changing the kind of what's being drawn there, but there's also compression and tension occurring in the spring. And if you change the speed of the motor, it should adjust the vibration seen and drawn by the machine.
Uh-huh. Great.
And there's currently, the damper is currently being used as well.
Okay, perfect. Okay, that's all for now. Thank you. Okay, Michael, please, can you show us the different parts of the unit again?
Okay. We'll start with the spring once again. This is connected here and here. The system, the height is adjustable, so you can adjust it if you need it to have the vibrations appear where you want on the sheet of paper. This is the mass carriage. It has linear bearings in here and has 2 pen holders attached, as well as this sensor that goes here and measures the vibrations. You can attach weights to right here up to 5 kilograms, which would be 6.7 kilograms total on the mass carriage, including the carriage. This is a Dashpot, which is a variable damper. You rotate it clockwise as seen from above to close the damper and therefore make it harder to move. This is the drum recorder. It has a synchronous motor underneath, which allows it to move at a constant speed. It moves at 0.02 meters per second, which allows you then to do calculations based on the drawings that are created from this system. In the back here, you can see the gears. You can't see that there's bearings and belts. This is the variable motor, which powers in here and then comes back through here to get to the crank, which causes linear motion of the support of the top of the spring. And so this just causes the spring support to move up and down at a variable speed depending on what is being done with the motor. And this is all covered in plastic so that it's as safe as possible, and from that area as well. And this is the other drum recorder, which records vibrations versus phase, or frequency versus phase of the vibrations. And this would also be able to be taken at the same time as the other one using a pen here and adjusted to the correct height.
Okay. And then what about the box?
The control box is here. This is the frequency display, which is taken from the sensor on the machine. This is the power button, how you turn it on and off. So I'll turn it off. And this is the drum recorder on-off button. So you push this and it starts rotating at 0.02 meters per second. Here is the on switch for the control, or for the motor. Yeah. And this is how you adjust the speed.
Okay. And this is, again, the free and force vibration unit.